minus lambda I plus t squared over 2 a minus lambda I squared plus da 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 da. All right? And the thing is, the thing that makes, the reason I call this the quote-unquote magic formula is because if you hit this formula with a matrix with the generalized eigenvector we just found, so let's look at it specifically. E to the ta times e2. So let's put in lambda equals to 3. 3t, we've got I plus t times a minus 3i. Sorry, I'm supposed to, well, I'm multiplying by e2, right? But hey, what's the deal with that? What's a minus 3i squared times e2? It's 0. So this is 0. This is e1, right? And what is this? This is a linear combo of columns, right? Of e to the ta, right? But one of the things we know about linear differential equations is that they're linear, like this linear combination of solutions is again a solution. Which means that this thing, whatever it is we're looking at, is a solution. In fact, this thing simplifies to e to the 3t times what? Times e2 plus te1. So there is your other solution in addition to the r1. This is your r2. And so just to get to the point here, before I give you guys some cookies stuff, where was I? Let me just,
Why is that expression equal to 0, the a minus 3i squared e2? Is that from the original matrix?
It's from what I just erased.
Oh, okay. Yeah.
I just erased, I had a minus 3i squared times e2. But yes, you have very good comedic timing. Let's see, what's that?
So a is the same as it was in the...
Yeah, now I'm applying this magic formula to the a we were looking at. And so the solution then in that one is the c2 e to the 3t. This would be, of course, 0, 1 plus t times 1, 0. And there you go, that's the solution to this 2 by 2. And this is there's a theorem which says that two similar matrices have the same Jordan form. Okay. All right. Let me say a little bit more about Jordan form, and then I'll give you some cookies. But I think I should say more for the sake of your homework. Yeah. If you look at the notes, I actually have these kinds of problems worked out. Like you'll find one that's similar, I think, to number 20 in your notes. And I do have, I mean, I can tell you the answer to one right quick. If I had, for example, this, if I had 6, 6, 6, oh no, 7, like that. This and zeros elsewhere, okay? Then this is what we're looking at here is the 3 Jordan block of 6 plus just a J107. So this gives me a minus 6i times E1 is 0, it gives me a minus 6I times e2 equals to e1. It gives me a minus 6I times e3 is equal to e2. And it gives me a minus 7I of e4 equals to 0. So, sorry guys. This one and that one, the last and the first, these are eigenvectors, right? But e2 and e3 are generalized eigenvectors. And in particular, the solution is going to look like this. C1 e to the 6t e1 plus C2 e to the 6t times, well, e2 plus te1 plus C3 e to the 6t times, let me write on the next line, plus C3 e to the 6t times, it's going to be e3 plus te2 plus 1/2 t squared e1. And then plus C4 e to the 7t e4. So there's another example without going through a lot of the details. That's how it would work out. So we can work with these Jordan chains. So there's like a chain of generalized eigenvectors here, like E3 is a generalized eigenvector of order 3. Just to emphasize, just a minus 6I cubed on E3 is equal to 0. But a minus 6I squared on E3 is equal to E2, yeah? Oh, I'm sorry, without the square. Yeah. And this one, we have a minus 6I squared on E2 is equal to 0. So E2 is a generalized eigenvector of order 2 with eigenvalue 6, and E3 is a generalized eigenvector of eigenvalue 6 of order 3. The other thing I should tell you about the Jordan form is if the matrix is in Jordan form, it's easy to decompose it as the sum of what's called of a diagonalizable matrix and a nilpotent piece. So I have a couple problems about that idea. It's really not a complicated idea, guys. I'll just show you right here. So this is equal to a diagonalizable piece plus a nilpotent piece. I forget what letters I used in the homework. Did I use D and N? Yeah. So just to tell you, like here, the diagonalizable piece is 6, 6, 6, 7 zeros elsewhere. The nilpotent piece is everything else. For the 3 by 3, the 2 by 2 we did earlier, this one, the 3, 1, 0, 3, that's equal to 3, 0, 0, 3 plus 0, 1, 0, 0. So this is the D part and this is the N part. And you can check it out, but D times N is always going to be equal to N times D. So they like commute. And there's always some power that when you raise N to, it's 0. It's nilpotent. So like here, N squared is 0, right? Whereas over here, N squared gets you to 0, 0, 1, 0, 0, 0, 0, 0, 0. This one has N cubed equal to 0. So like a 3 by 3 block, a Jordan 3 block will have a nilpotent order 3 or degree 3 thing, and so forth. Like if you got a 4 Jordan block, you'll have like a nilpotent degree 4 piece, and so forth. All right, guys. So anyway, I'm sorry. I wish I could get started in here like 5 minutes earlier, so we wouldn't end up going so late. I do have donuts. I hope that makes up for it. I'll tell you what, I will collect the mission at the end of class Thursday because I feel like I still want you guys to have a few more minutes to ask questions about it and sort of wrap up your solutions. So I'll let you write about your, you can write more all of class Thursday. I'll collect it at the end. And I want to discuss the solution with you too, so I think everyone should get a pretty good score on this mission, yeah? understand what I'm saying? Yes. Okay. So, I mean, I realize an hour is not enough time to write everything down either, is it? But I hope you understand the spirit in which I do that. And of course, it has nothing to do with course evaluations. Let's hear. So, this is my in-class course evaluation. If I could have a volunteer to collect them from everybody here and just take them to the math department and slide it under the door to the math secretary, she's long gone by now, then I will not look at these until, I've assigned grades in here. So you have my promise. And the reason I do these is a couple-fold. One is I actually want to be able to give you a forum to write advice or whatever about the course in longer than like 20 characters, which seems to be the length of the online one, I don't know if you've noticed or not, but if you start writing more than about like 3 sentences about a course, it's like, bleh. You know what I'm talking about? Or at least that's how it is for me. And then the other thing is, I just have some helpful comments here about like, so if you look at these, what I have in italic is, these are the things that I have added. For example, I'm most proud of the extra things I have written in number 17. So number 17 is, the course integrated the subject with biblical principles. That's the actual course evaluation questions. Here's my add-on to that is that notice that all truth is God's truth. To answer negatively here would be to say that math is not part of God's truth. Do you really want to be that person? I'll say that, I'm sorry. But so I'm also proud of number 11. Would you recommend this course to your friend? Assume your friend has similar life goals. This question is not asking you if someone from a non-technical major should take this course. We all know that they shouldn't, right? We know it. That's not up for debate. Yeah. Is the amount of time required in this course reasonable? Like, this is not asking you if this course took you the same amount of time as like, there you go. I'll let you guys fill in the blank as to not be in political deep waters here. Let's see here. But anyway, I do appreciate your feedback, and I thought that might be useful. And to make up, at least in a small part for your time, here's some munchkins. So you can, and I also have milk, which I will be bringing around. I promise I will not be looking at your, and I do need a volunteer to gather these together and take them to the math department. You can do it? All right. So when you're done with your evaluation, just bring it to, by the way, I still would appreciate if you do the electronic one because this one doesn't actually count for the university. So I guess I should probably emphasize that to my other classes. And I have some quasi-cold milk here. I'm sorry I had to bring it at the start of class. I mean, it's not as cold as I like personally, but I say, who wants milk? I mean, it's good milk. I'm not saying it's bad or anything. It was in the refrigerator before class. It's not skim milk. No, heavens no. If I wanted skim milk, I'd get whole milk and get a gallon of water. You look lactose tolerant. There you go. And you?
Yes.
Ah, you found the donut. You're wise.
Thank you.
Hey, that donut is an illustration of why meal swipes are such a bad deal. Because the girl before me was like, "You want 2 donuts?" I was like, "Sure." So that donut was free. Yeah. I'm debating whether or not I'm going to get my differential equations class. Thinking, should I get them the smokehouse? What do you think? I don't know. They've been pretty well behaved this semester. Maybe I owe them the mochified. Oh, wait a minute. Yeah. Who am I talking to here? Completely unbiased opinion.
Yeah, unbiasedly.
I mean, it also means I get to eat another slice of the mochified pizza, so it's kind of a win-win. Uh-huh. I found out my Calculus 3 class really likes coconut cookies. Like, they destroyed a package of coconut dreams I got this morning. There you go.